Can we scrape every AI company's privacy policy to find out who trains their models on public data? Let's scrape that. Every company is AI powered now. But under all the hype, there's one constant truth. Models are only as smart as the data they're trained on. You feed a model billions of examples, text, code, images, conversations, it looks for patterns, builds internal connections, and adjusts itself again and again until it can predict what comes next. That's how it learns, by recognizing the structure in the chaos. Either way, what goes in is defined by what comes out. The better and narrower the data, the smarter the model. So naturally, the big question is, where does all that data come from? And more importantly, which companies actually admit to using public data in training? Well, we will find out in 3 steps. Step number 1, find as many AI company domains as possible. Step number 2, locate their privacy policy URLs. And step number 3, scrape and analyze those policies for key phrases that reveal how they use their data. It sounds simple. It's not. Let's get into it. Step number 1, finding the company domains. The first problem is that there is no central list of AI companies. You can't just Google that and get a clean dataset. Results are fragmented across pages like Crunchbase, GitHub, TechCrunch, articles, directories, blogs. The list never ends. If we tried scraping that manually, we'd hit captchas, IP blocks, and rate limits, some almost instantly. So for this, we're using Bright Data's SERP API. It lets us query search engines directly and get structured JSON results. Now, to get started with using Bright Data, we actually need to register ourselves on brightdata.com. It's free to start, and it's actually very simple because once you created your account, you just need to navigate to your dashboard, click on the SERP API, create your first zone, and then you'll be able to get your API key, and you can actually start running queries. Now, when it comes to the queries, it's actually very, very simple because as part of the payload, you provide 3 different values. The first value is the zone. That's the zone that you get from creating your SERP API. Then it's the URL. That's the really important part because that's where you're going to be searching and passing in your queries. Now, I'm going to be searching on google.com and I'm going to pass in a large array of queries. We'll get to that in a second. And finally, as part of the payload, you pass in the format that you expect to be output. Now, you can specify for this data to come in raw, or you can set that data to JSON. Now, I feel like working with JSON is a little bit easier, especially when we're writing code, so that's what I opted for. But how do I go about this and take this even further? Well, actually, what I did before I started is I went onto ChatGPT and I asked it to create a very large amount of diverse queries, which all will lead to point to a particular or a variety of different AI websites. And I asked it to generate those diverse queries for me. And the result of that is that I got over 100 different things that I would be iteratively running through the SERP API to get some results. Not only that, for each one of these search queries, I wanted to search that specific phrase in multiple different countries. So what I created is a list of target countries that I want to search through, 25 plus in total. And for each country, I'd search each one of the phrases, collect the results, accumulate them in a JSON, look and eliminate the duplicates, and get a final result of domains. Now that worked really, really well. Now, the first time I ran the SERP API to search through all my queries, this took 38,705 seconds. That's almost 11 hours. I had to leave it overnight. But luckily, Bright Data allows us to create asynchronous requests. Usually you would use asynchronous requests when you have very large volumes of data, or maybe some pages are slower, or maybe you have some long-running queries that you need to execute. And then it sends that request and then accumulates all that data after some time. And I have done that. And not only that I ended up getting over 2,000 more domains for some reason or another, but also it ended up taking much less. It's just over 3 hours from what I believe. and it ended up generating a really nice data set of very different domains that I would be able to search for to get some really cool data. Now, when you're working with asynchronous requests on Bright Data, you have to go back to your dashboard, you have to go to the specific API, go into more advanced settings, and enable the asynchronous requests option. And just to add some context, if I switch to a full parallel execution, this could run in seconds, not hours. That's because instead of processing each request one by one, you run a huge number of them at the same time. Either locally, if you have a very powerful machine, or you could do it in the cloud with Lambda functions. When everything runs at once, the bottleneck just disappears. And it's really awesome that Bright Data fully supports this kind of high throughput real-time execution. All right, well, now that we have hundreds of domains, the next challenge is that every company hides its privacy policy differently. Some host it just under /privacy policy. That's the easy part. Others, they have it under /legal/privacy /policy/privacy /about/privacy. And then there's some that are global split and have them by region /US/privacy policy or /EN/privacy policy. Some even host them elsewhere on different subdomains. So how do we approach this? Well, that inconsistency breaks the simple URL guessing. So for this, we will keep using the amazingly powerful SERP API, this time for site-specific searches. And what I ended up doing is I ended up writing down a bunch of common paths that could potentially work for the specific domain. Things like /privacy policy, /privacy, /legal privacy policy. I kind of went through a combination of the typical most popular ones that we could expect. It worked for 90% of the websites. And for the remaining 10% that just didn't work, we would use the SERP API again, directly target the domain name, and search for a specific keyword or a slug so it understands the whole page and it searches for that whole particular domain to see if we can find it anywhere in the page structure and navigate as to it. Now, the SERP API has done incredibly well because from the total amount of domain names that we have collected in the first round of scraping, we actually ended up being successful with 97.6% of the domains and being able to find their privacy policy. That is a result. Now we've come to the fun part, fetching the actual text. But here's the catch. Half of these pages load dynamically or sit behind some protection layer. You hit them with a normal scraper and you'll end up getting empty HTML, 403s, or region-locked content warning. This is where the Bright Data Unlocker API actually comes in. It handles all of that. JavaScript rendering, bot detections, redirects. So when we actually go ahead and fetch a URL, we get the real rendered page that we can analyze. From there, we'll extract the text and search for certain key phrases. Once we've processed all of them, we'll have a clear picture of who's transparent about the data practices and who isn't. Now, if you want to use the Unlocker API, again, you have to navigate to your dashboard, you have to create a zone for the Unlocker API, and then you'll get your API key. Now, again, for the Unlocker API, we also used asynchronous requests. In the same way we learned from the previous example, it's going to be much faster. Now, in a very similar way to the SERP API, the Unlocker API also takes a payload, and as part of the payload, you need to provide a URL and the format that you want to receive the data back as. In our case, for the URL, well, we had the full URL ready. It was the website domain with the /privacy policy or whatever the path was to get to the privacy policy. And for the format, which is what type of format we want to get it back in, whether it's raw or JSON, well, we just went with raw because really all we need to do is just analyze the text. Now the question probably is, well, how did we analyze that data that is coming in from the Unlocker API? Because the Unlocker API in this last part of the example, all it's doing is it's running a for loop through all of the domains with the specific endpoints that point to the privacy policy, and it's fetching all that raw HTML. A lot of you might be thinking, oh, well, you could have connected it to OpenAPI or Claude and fed it all that data and have it analyzed for you and get a very accurate result. Correct, I could have done that, but that would have been millions of tokens. Privacy policies are absolutely huge. And if I wanted to iterate over 5,000 websites, I would go bankrupt, right? I would go bankrupt. So I wanted to come up with some kind of my own logic and a little bit of heuristics to be able to analyze the HTML and come to a conclusion myself. Now let me show you a little bit of my code. I ended up creating a bunch of training phrases, which is things that I want to look for in the raw HTML that I get back from the Unlocker API to be able to see if this type of text already exists in the actual raw HTML. So I created a bunch of these training phrases, these private data phrases, data usage phrases. And then on top of that, what I also did is I created these proximity combinations. If one phrase and the other phrase appear close enough to each other, it probably gives a higher probability that they are related and that we're talking about the same kind of concept here. And the idea was to check whether the privacy policy mentions that they train data on user data. In this case, you have the word train here and personal data, and we check for that proximity. And then, I would go through the process of cleaning the text, finding the phrase positions, I would check their proximity, and then I'd come up with a probability. After collecting all that data, analyzing it, looking at the heuristics, the probability, and analyzing a total of 5,583 companies, from my results, I can officially say that 12.4% of companies out there in their privacy policies use your publicly obtained data from tracking you on their webpage or from you registering in their product to train their large language models for better effectiveness and efficiency. Now the question goes out to all of you. Is 12.4% a lot? Or maybe is the other high percentage of companies just not officially declaring it in the privacy policies? Make sure to like, subscribe, and register yourself for Bright Data to have some fun with scraping on the web. And in the comments below, leave your suggestions of what we should scrape next.